coding agents like Cursor and Claude are incredibly fast. You prompt them, and thousands of lines of React components appear in seconds. But a high percentage of that code is structurally flawed, fracturing under the surface with unnecessary effects and bloated re-renders. Because the output looks functional, developers often accept these hallucinated components and push unoptimized architecture directly to production. That brings us to React Doctor, an open-source repository by Million designed to act as an immune system against these specific AI-generated flaws. It has seen a rapid rise to 8.4K stars on GitHub as teams look for ways to audit machine-generated code at scale. The project's premise is stated in its slogan: "Your agent writes bad React, this catches it." But introducing such a rigid tool into your pipeline creates a trade-off. You have to decide if this is a necessary defense for your codebase or a configuration hurdle that will slow down your deployment cycle. Trusting an AI to build your architecture without a specialized guardrail often leads to a buildup of technical debt that requires significant manual labor to audit and fix later. The tool works by running a base scan across your project to generate a strict 0 to 100 health score. This chart shows the point deduction system. For every unique error rule, the system deducts 1.5 points. It removes 0.75 points for every warning rule. The score focuses on unique rules. If an AI uses an anti-pattern 50 times, you only receive a single penalty. This logic forces you to address the root architectural mistake. Fixing the rule recovers those points. This has created a competitive environment, with a public leaderboard showing how different codebases rank. High-profile projects like TLDraw and XCalidraw are used as benchmarks for a high-quality React score. This 0 to 100 system provides an objective benchmark for code health, moving the review process away from subjective developer debates. While catching bugs is useful, the tool is also designed for proactive training through the install command. Running this command injects .cursorrules and other agent-specific files directly into your project. As this diagram shows, these files act as a filter that the AI must follow when generating new code. By embedding these rules into the workspace, you train the agent to follow React best practices before it ever writes a line of code. For projects that already have established workflows, the tool also operates as a standalone lint plugin. It integrates with high-speed engines like Oxlint, allowing you to run these complex React checks across your entire project in milliseconds. Keep in mind that if you already use a complex ESLint setup, you will need to manage parallel configurations to keep your linting consistent. The combination of age-of-level rules and plugin support provides a dual-layer defense, serving as both a standard linter and a persistent supervisor for your AI agent. However, applying these strict rules to an existing project can be a difficult process. On a 3-year-old monolithic codebase, the scanner often flags hundreds of legacy patterns that no longer meet modern standards, which can be overwhelming. In these cases, it is common for a project to receive an initial score below 50, which the tool labels as critical. This creates a significant workload, as you'll need to write extensive ignore rules in the configuration file to prevent the scanner from blocking your pipeline. You can use the diff mode to reduce this noise by only scanning files that have been changed in a specific PR. The catch is that using diff mode disables the tool's ability to detect dead code. This is because the underlying engine, knip, requires the context of the full project to determine if a file is actually being used. While React Doctor provides a strong defense for new code, retrofitting it onto years of technical debt requires a heavy upfront investment in configuration. This decision tree helps determine your best path forward based on the current state of your project. If you are starting a greenfield project or relying heavily on AI agents for feature development, you should install the tool immediately. The local .cursorrules injection is a mandatory defense when you are generating architecture with AI. For legacy maintainers, the path is more cautious. You should start by running the tool in a non-blocking mode. The initial health score on an older codebase will likely be low, which can be disruptive if the tool is set to fail the bill automatically. Start with the Fail on None configuration. This allows you to see the diagnostics and slowly improve the score without stopping your team's daily work. Regardless of your project's age, if you are using AI to write React, you need a specialized static analysis tool to verify the output. If you want to stop your AI from destroying your React performance, hit subscribe and check the link below to explore the React Doctor repository. See you next time.